Boom. So this is definitely a cone related rates question.
We're doing number 2.
Yes, we are. Oh, man. So, why are you all making so much noise all the time? Okay. It's being filled up with water. So there's the water. Boom. It's getting hit. The water's going in at a rate of 12, but it's coming out at a rate of 4.
So like in 8. So you'd be 12 minus 8.
So dV/dt, the rate of change of volume is positive 8 cubic inches per second. Okay, that's dV/dt. And naturally, I'm going to ask you how fast the surface of the water, how fast the radius is changing. So we want dr/dt. Yep, so we need an equation, again, linking volume to radius, and we're going to derive it. With a cone, it's not a surprise, this is going to be the volume is equal to 1/3 pi r squared h, okay? I should label this picture here too, I guess. It's 10 inches across, which means the radius of the big cone, which is not changing, is 5 inches, and the height of the big cone is 8 inches. Also, those are not changing. Those don't have derivatives. We use those to get the ratio of what r and h have to be, or r to h, okay? So, what that means is, let's draw this in a different color here so this stands out a little bit, is that this triangle down here, boom, must be similar to this larger triangle, which is terribly drawn, but that's a triangle. All right, stick with me. There you go. And we know that the dimensions of the big triangle are 5 and 8, and the dimensions of the little triangle are changing. So we give those variables. But what must always be true, regardless of the volume in the tank, is that r over h must equal 5 over 8. And the reason why that's important is because when I derive the volume equation, I'm going to get a dr/dt and a dH/dt right now. And I don't want that. All I want is dr/dt. So I'm going to use that little proportion to sub out h. Okay? So when you solve this, you get that h is equal to 8/5 r. Everyone okay with that? Just cross multiplying. So that means the volume is going to become 1/3 pi r squared times 8/5 r. And we're going to simplify this. When you put all that together, the 8/5 is going to be times the 1/3, so that's going to become 8/15. There's a pi in there, so put that up top, and then it's just r cubed. And this ends up being really easy to derive. When we derive it, we're going to get dV/dt on the left, which we know is equal to 8 pi over 15 times 3, which the 3 is going to cancel with that denominator, times r squared times dr/dt. We want dr/dt. dV/dt happens to be 8. This is going to be, the 3 is going to cancel with the 15, so that's 8 pi over 5. I'm not really sure what r is yet, and I'm looking for dr/dt. Okay? So to find out what r is, we're going to go back up to the problem and see what they're saying to me. In the problem, they tell me that the surface of the water at the point in time we care about is 5 inches deep. Well, the surface of the water being 5 inches deep means that h has to be 5. Okay? So if we come back down here and plug in 5 for h into this equation here, cool? Or the second one, really doesn't matter. We're going to get r over 5 equals 5 over 8. That has to be true. So r has to be 25/8. And we're going to square that. It's r squared going in there. So r squared, 25 squared, 625. And 8 squared is 64. And we really don't even need to square that 25 because we're going to cancel with the 5 anyway, so it's going to simplify down a little bit. Okay? But simplifying this, we're going to get 8 is equal to, the 8 and the 64 are going to cancel out. You okay with that? That makes that a 5. And then the 5 and the 625, it makes it an 8. And the 5 and the 625 cancel out, and it makes that a 1, and it makes this up here 125. So really you have 125 over 8. And the pi is still there. Is that okay?
Yeah.
And then we'll solve for dr/dt. We're just going to multiply by 8 and divide by 125 pi. So dr dt is 64 over 125 pi, and that's going to be in, what are our units? Inches per second. We used the fact that the radius and the height had to make a proportion. Right there. And we knew the height was 5. Cool? So our final answer is 64 over 125 pi inches per second.